Okay, this is prerequisites for grade 10 academic math. Evaluating radicals. Okay, so when we evaluate radicals, one of the ways you can do it is if you use your calculator, you can submit this and you're going to get the value. You also know that since 7 times 7 is equal to 49, the root of 49 is equal to 7. Since 0.4 times 0.4 is equal to 0.16, the root of 0.16 is equal to 0.4. So we know that the root of 4 has to be two numbers multiplied to each other that would give you 4. So in this case, 2. Okay, we know the root of 25 is equal to 5. Okay, I think 1.69 would be, I think 13 times 13 is 169, is that right? Somebody do that on their calculator?
Yeah.
So I believe the square root of 1.69 would be 1.3, is that right?
Yeah, it's
1.3, right? Okay, so you see how I did that? So I want to know what 169 is. I know 13 times 13 is 169. The decimal was there, so I did 1.3. All right? 0.81 would be 0.9, right? Okay? Moving on. Evaluate to the nearest tenth. So in this case, the square root of 3422, you would need to use your calculator. So what's the answer in that? What comes up on the calculator? 58.5. Yeah, so it says to the nearest tenth, so we would leave the 0.5. The tenth is the first value after the decimal. All right? Square root of 747. Should we get a calculator here?
You round that to it? Yeah, it was round.
Yeah, you round it to the tenth. So if it's like a repeating decimal, let me just see what it is. Sorry, what is it equal to?
27.3.
Okay, so you would leave it to 1/10. You would leave it like that. All right, expanding expressions. This is very, very important. Important skill to have. This is going to be on the next quick prerequisite assessment I'm going to give you on Monday. Okay, so very, very important. I'm going to choose the two hardest ones here down at the bottom. Okay, now where most students get tripped up on this is the negative signs. So please pay special attention to the negatives. I'll deal with one of these as well. So let's do E first. So I'm going to do E up here. Okay. So this negative sign needs to be distributed to both terms in the brackets. So you're going to end up with negative 2x plus y. All right? Any questions on that one? How the negative gets distributed? Okay. Next one. We're going to answer h down here. So we have x times x squared minus x plus 5. This x needs to multiply to each one of the terms in the bracket. So we have x times x squared. What does that give us? Yep. X cubed, very good. We add the exponents when we're multiplying powers. X times negative x is equal to, what's this? RC. X times negative x. X times negative x, what would we get? Hold on, I'm asking RC. 1 second. Sorry? You're right, it's negative x, but what? When you multiply x times x, what do you get? Yeah, negative x squared. Good. All right. Rudy, x times 5? 5x. Good job. Jafet, right?
Yeah.
You're going to do this one all the way, okay? Go.
3a times negative 3a cubed.
Yep.
Negative 6a cubed. I mean squared.
Yep.
And negative, positive 3a.
Excellent. Any questions on that? Yeah, Leo.
I'm asking, can you run
1a, sure. 2 times x and 2 times 3. What's 2 times x, Leo?
2x.
What's 2 times 3?
6.
Oh man, that's it. Okay? All right, exponent rules. When we multiply powers with the same base, you add the exponent. So here we have a x squared and an x3. 2 plus 3 is x to the exponent of 5. Now, one of the biggest kind of things that students miss is if you have something like this, x times, sometimes you can use period as multiply. What's this equal to? Alan. X9, yes, excellent. Good job. There's a little invisible 1 there, and it messes a lot of kids up. It's 1 plus 8, x to the exponent of 9. Okay? When you divide powers with the same base, you subtract the exponents. Okay? So when you have x over 8 divided by x over 3, what's this, Douglas? 8 minus 3.
5.
Yeah, x to the exponent of 5. Good. All right. When you raise a power now, so if I have x to the exponent of 3, all of that raised to the exponent of 3, what's that give me, Josiah? You don't know? When you have a power and you raise it to exponent, you multiply the exponents. So what would it give us? Sorry? Yeah, what would the full answer be though? X to the exponent of 9, good. Yeah, that's good. All right? Moving on. Simplify using the exponent rules. This is one of the easiest things, the exponent rules, I find. They're just simple addition and subtraction. All of these are very easy to do. We're going to do C, F, I, and L. Okay? I'm going to get Alex's help with C. Alex, can you do this one? What's 4 squared times 4 cubed times 4 squared? So remember, when you multiply powers, you're adding the exponents. So what's 2 plus 3? 5, yeah, and then you need to add another 2. Good. So we have 4 to the exponent of 7, right? You with me? RC, 3 to the exponent of 7 divided by 3 to the exponent of 4.
3 to the exponent of 3.
Good. Okay, Andrew, 3 to the exponent of 4 multiplied, or sorry, raised to the power of 3.
3 to the exponent of 12.
Excellent. Okay, Maxis, y to the exponent of 5 divided by y to the exponent of 4.
Is that a divide symbol or is that a...
It's divide. Now, let me ask you a question. What is y to the exponent of 5 plus y to the exponent of 4?
Y9.
What's this?
Y9. Like y power 9.
Okay, it's not. Anybody know the answer to this? Yeah.
Y to the power of 14.
Y to the power of 14. Y9, I heard. Y to the power of 14. Anyone else? Yeah.
Y to the power of 5.
Y to the power of 5.
Y to the power of 20. Y to 13. Y9.
Anyone else?
Sorry,
Yep.
Just 1.
Just Y?
Sorry, I thought the 4 was a 9. My bad.
Okay. Here's the better question. Can we add these two?
No.
You said nah.
Yeah.
Nah. You're right. Nah, you can't add them. It's just like saying A plus B. They're different variables. That's what's messing a lot of you guys up. You cannot add y to the exponent of 5 plus y to the exponent of 4. You cannot add them. Okay? Can you multiply them?
Yeah.
What's that equal to?
Y to the power of 20.
Sorry?
Y to the power of
Stefan.
Y to the power of 20.
Of what?
Power of 20.
Y to the power of 20. Nope. Come on, we just went over this. Adrian.
To the power of 9.
Right, y to the power of 9. So when you're multiplying powers, remember a power is a base with an exponent, you add the top. If you're adding the powers, you can't add them because they're not the same, they're not like terms. Remember, like terms are dictated by the variable and the exponent. They both have to match, not just the variable. All right, we're going to do this last one here. R minus 10m7 divided by negative 2m3. Who can tell me this one? Leo.
So would it be negative 5 M4?
Ooh, very close. Not negative.
Oh, 5 M4,
Yeah, not negative but positive because we have that double negative going on again. Okay? Chenier, you got a question? Ask me. Which one?
I was just saying that I didn't really understand how, like, you see how you said you can't do y5 plus y4?
Right.
But then when you went down there, you're still, like, adding the 5 and the 4 at the top.
Yeah, let me explain that. Okay. Let me explain that. Okay. When you have a power added to another power, so a power is the whole thing. Okay? This is the exponent, and the whole thing is called a power. When you add powers, you cannot add two powers together if they are not common. They don't have the same variable and the same exponent. They're not like terms. You cannot add them. So what this is equal to is just this. It doesn't change. Okay? When you multiply powers times, now you can combine these two terms. Because you're multiplying, you add the 4 and a 5, so this becomes that. Okay? Is that clear? Yeah.
Does the coefficient also change?
The coefficient?
Yeah.
When you're multiplying, yes. Yeah, like if you have 5y4 times 2y5, this you multiply, yes, the coefficient as well as the top. So this would be equal to 10y9. Okay?
How about what if they're one?
What?
What if, like,
If this was just a 1y?
Yeah.
Yeah, it would just be 1 times 2, so it would be a 2.
If both of them were one.
Oh, then it would just be 1. Right? Yeah.
What if they were both the same number? Like, what if it was like y5 plus y5?
Okay. If it's y5 plus y5. Are these like terms?
Yeah.
Can we add them?
Yes.
Stefan, what is 1 plus 1?
2.
Nice. Nailed it. 2y5. Right? Good. Okay. First differences. Now, first differences are calculated from tables of values. All right, you guys remember first differences? Who could tell me what we use first differences for? Who remembers? Yeah, it's to do with lines. Who said that? Andrew?
Yeah.
Okay, you're right. It has to do with lines. And what does it tell us when the first differences are the same? Yeah, Andrew?
That means it's a linear.
Yeah, it's linear. It's a straight line. Very good. Okay, so in this case, how do we find first differences? Do we worry about the x values?
Right.
Do we need to worry about the x values?
No.
I don't know.
Not sure? We have to, the x values need to increase the same amount. Okay, so we do kind of need to worry about them, but to calculate the first differences, we are actually using the y values. Okay, so the first differences are y2 minus y1, y3 minus y2, and y4 minus y3. So we're subtracting our y values. So here we can see 5 minus 3 is 2, 7 minus 5 is 2, 9 minus 7 is 2. Okay? Almost always, your x values here, if you're given a table of values, they're going to give you these values that have the same amount of difference between them. Like these are adding 1, right? They're all adding 1, every single one of these, okay? But that would be important to note, because if you don't add up the x values at the same rate, the y values would not be the same for a linear relation. All right? But the main thing with first differences is we want to check whether or not they're all the same. If they're the same, we know it's linear. If they're not the same, so 4 minus 1 is 3, 9 minus 4 is 5, and 16 minus 9 is 7, we know that this relationship, this graph, if you were to graph it out, right, here's our x, here's our y, is not going to be linear. It's not going to be a straight line. Any questions there? Any confusion on that? It's pretty simple stuff, right? So for this one, RC, you're going to help us out. What's 14 minus 10? Oh, sorry. 14 minus 10. Sorry? 4. Good. What's 10 minus 6? 4. What's 6 minus 2? 4. Okay, so is this relation linear or non-linear?
It's linear.
It's linear. Good job. All right, this one I'll do quickly. 17 minus 10 is 7. 10 minus 5 is 5. And then 5 minus 2 is 3. Is this non-linear? Non, and this one is linear. Any questions? Okay. Lucas, what does first differences tell us about a graph? Right? Yeah, that's it. If it's linear, that's it. Graphing. I know everyone's favorite topic, right? Graphing. I know you guys love graphing. Graphing never stops. It never ends. Can't stop, won't stop the graphs in math. Love graphs in math. Grade 11, more graphs. Grade 12, all graphs. Graphs don't stop. Yep. 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 Nope. After the lesson you can. Okay. Graphing equations. To graph the line x plus y equals 6 using a table of values, choose suitable values for x. Complete a table of values by finding the value of y for each value of x. So here, we actually pick the values of x. Okay, now when it says suitable values of x, usually you hover around 0, right? And that's what he's done here. He chose 5, 3, 1, -1. I don't know why he didn't choose -3, -2, -1, 0, 1, 2, 3, but those are the choices he made for x. He's hovering around the origin. Next, you take those values and you sub them in to the value of x, and you solve for y. Okay? If I take the x value here, 5, I put it in for x here, 5. To isolate y on its own, I got to move the 5 to the other side. It becomes -5, and then I get y equals 1. Any questions there? All right, that's how I get my table. To graph, everyone understands the x value comes first on a point.
Yeah.
The y value comes second. Don't forget that. It's just like the alphabet, x comes before y. That's a good way to remember it. Okay? Yep.
Could we just put them, instead of moving the x value over, could you just put x and y into the equation?
It would just give us 6 every time.
I know, that's what I'm saying, so wouldn't that be another way to do it?
No, because when you're graphing, usually you don't have these values. You're trying to find them out.
Oh,
Okay? You're right, but yeah, we already have them, so yeah. All right, so it says next question, graph each equation using a table of values. So we're going to do one of this because it's going to take a little while here. Let's do the last one because it tends to be the hardest. So here's our equation, y equals 2x plus 1. Now we need to create a table of values, so I'm going to draw the table here. Okay, we're going to have x and y. Okay, and then I need to choose my x values. The x value, remember it comes first, it's the one we get to pick. So I'm going to choose -2, -1. Remember you want to increment the same amount, 0 and 1. Those are my values I'm going to choose. Okay, let's do one more. And 2. All right? I'm going to use this graph here since it's just above. I'm going to graph this up here. The first step I need to do is figure out what my y values are. Okay? So how do I do that? I need to substitute in -2 in for x. So my first y value here is going to be y equals 2 times -2 plus 1, which is what? RC. Good. -3. Okay? Next y value, right here. What am I going to do? Douglas, what am I going to write here? Y equals?
Y equals 2
times -1.
Good.
1.
Excellent. And what's that?
1. -1.
-1. Good. 0 is really easy. The 2 becomes what? Josiah, when I do 2 times 0? 0. So what does y become? 1. Yep. Okay, Chenier, next one. You're going to sub in 1 for x. So y becomes what? Nope. Right here, Chenier, we're subbing in 1 for x. So what's the y going to be equal to?
So the 2 is probably 2 times, so like 3.
Yeah, 3. Good. Okay, 3. And then the last one, Andrew, you're going to sub in 2 here for x. So you're going to have 2 times 2 is what?
2 times 2 is 4 plus the next 5.
Excellent. So there's our table of values. Now the only thing left we need to do is graph it. So we start off with x is -2, y is -3. So I go 1, 2, 1, 2, 3. There's my point. Next one, -1, -1. There. Next one, 0, 1 here. Next one, 1, 3 here. Next one, 2, 5 here. So there's my line.
Sir,
Yep.
for this, when we do this, right, we need to make a graph and do 5 dots. Or
Yep.
can we do 5 dots?
Probably get away with 3.
Okay.
Yeah. We know it's a straight line because we can check the first differences, right? 5 minus 3 is 2, 3 minus 1 is 2, 1 minus 1 is 2, -1 minus 3 is 2. Okay? Because it becomes -1 plus 3, which is 2. Any questions on first differences, graphing? All right. We are going to move on down here now. And it says, to graph x plus y, 2y equals 6, using the intercepts, find the points where the graph of x plus 2y equals 6 crosses the x and y axis. So this is like a really easy way to do it, right? We know this line will cross the y-axis when x is equal to what? 0. Yeah. Because the y-axis, that line is actually x equals 0, right? Because we know x goes this way. So if I sub in x equals 0, which is down here, into this equation, I get 2y equals 6, so y is equal to 3. So when x is 0, y is 3, this point right here. Okay? Next, I can try to find out what the value of this line will be when the line crosses the x-axis. And in this case, the y value when you cross the x-axis is going to be what? 0. So I sub in 0 for y, and I get x equals 6. So then I count 6, boom. And then I already have my line here. Okay? Watch how quickly that would have got us our line here. So this is the one that I did, right? I did this whole table of values up here. Watch this. If we just used intercepts, I could have said y is equal to 0. So x is equal to -1 divided by 2. So -1/2. So when y is 0, x is -1/2. Can't really see it too well, but it's... Let's zoom in. It would have been this point right here. The next one, if I subbed in x equals 0, I would have got y equals 1. So it would have been this point here and this point here. So those 2 points right there, I would have had that same line. Okay? Yeah.
So how did you get, for the one where it's 0 equals 2x plus 1, how did you get -1/2?
Okay. 0 equals 2x plus 1. This was my y value. I subbed in 0. If I move the 1 to the other side, Leo, I get -1 equals 2x. Right? Now what do I have to do to isolate x?
Divide. Oh, yeah.
Divide by what?
Divide by 2.
Good. So divide by 2, divide by 2. See, when I skip one step sometimes, I lose people, right? X is equal to -1/2. Okay? Any questions there? All right, we're gonna go right down to 2. It says graph each equation using the intercepts. So here we're gonna do D. So in this case, I want to say when y equals 0. So I'm gonna sub in 0 for y. I get 2x minus 5 times 0 equals 10. And I get 2x is equal to 10, x is equal to 5. Likewise, I'm going to say when x is equal to 0, I'm going to sub that in for x over here. So I get 2 times 0 minus 5y equals 10. And I get minus 5y equals 10. Y is equal to minus 2. Any questions? Now to graph that, you would graph y is 0 when x is 5. So if here's my graph, y is 0, x is 5 right here. Watch it be the same line. When x is 0, y is negative 2. So here, that's my line. Sorry, I went through. Yeah, you're right. My bad. Who said that? Who caught me? Adrian? Thanks. Okay? Any questions on graphing? We good, right? I hope. Moving right along. Okay, this looks like the same stuff here. We're on 3. Graph each equation using the slope and y-intercept. Oh, the only difference is they're asking us to graph it. So again, the process would be the same. For D here, you would first sub in 0 for y. You'd get 3x minus 1. Then you'd get 3x is equal to 1. Then you get x equals a third. And then you'd sub in 0 for x, so you'd get y equals 0 minus 1. Y equals 1. And then you would use these 2 points. You'd have 1/3 0, and you'd have 0, 1, and you would graph those 2 points, and that would give you your graph. Okay, yeah?
What do you do with the 1/3 with the x?
Yeah, so on the graph, you would have to put it like, so it's 1/3, 0, so it would be very, very small, but you would put it, so this is 1, right? This is 2, so 1/3 would be right here. You get it? Yeah, pretty annoying to graph. You'd have to like blow up the graph. Do you know what I mean? You guys have a question? Josiah?
No, I don't.
You're good?
One more question, sir.
Yep.
Zoom it back up a minute.
Yep.
It's with the y, where it says y equals 0 minus 1.
Yeah.
Why does y equal 1?
Because oh, sorry, you're right. It should be -1. Thank you. Caught me. Good job. My bad. Good catch. Any other questions with that one? It's the same as the other one. It's just asking you to graph. Okay, number 4. Graph each pair of lines and find the coordinates of the point of intersection. All right, so let's talk about this now. It says to find the point of intersection of the lines y equals x minus 3 and y equals 5 minus x. Graph the lines on the same set of axes. So we've graphed these 2 lines, and now we have the point of intersection here. That's using a graph. Okay? It says graph each pair of lines and find the coordinates of the point of intersection. So you would have to graph this out again using the y-intercepts would be the easiest way. You could do it with a table of values, but the easiest way would just substitute in 0 for y and then 0 for x, and you get your line. 0 for y, 0 for x, you get your other line, and see where they cross. Okay? Did you guys learn substitution in grade 9?
Yeah.
Yes? No? Got double answers? Okay. Another way to do it is substitution.
I don't remember what that is.
I don't know if we're going to cover it here. Okay. Well, if we don't cover it here, then it'll be in the grade 10. I don't see it, so you probably didn't. Oh. No, I don't see it. Basically, you set the y variable is equal, so you'd have x minus 4 and equals 8 minus x, and you solve for x. It's a little bit shorter. For now, you can just graph them. All right. Greatest common factors. To determine the greatest common factor, GCF of 4c squared d and 6c d3. Write an expression as a product. Then write the factors that are common to both. Ooh, this is long.
Sir,
This is a really long way to do it. Yep,
so we're not gonna go over finding the point of the intersection?
I just did. You graph this line and you graph this line, and then where they cross, that's the point of intersection. Okay? Yeah, I've already done like 2 or 3 graphs now where I graphed a line. You just graph 2 of them on the same graph, and where they cross, that's the point of intersection. Okay? Okay? Ethan, good?
Yes, sir.
All right. Greatest common factors. This is a really long way to do it. Look what they've done here. They've taken this term and they've stretched it out. They've added 2 2's, they've added 2 C's and a D. And for the 6, they've done 2 times 3 times C times D, D, D. Wow. And then they say, determine the the greatest common factor of 4C squared and 6DC is 2 times C times D, or 2CD. So how do they do that? They go 2 times C times D. I guess the way they do it is they cross out. Yeah. Yeah, I don't really like this at all. I would say, like, the greatest common factor, this is the way I do it. Just, what's the biggest number that goes into both? Okay? It's not 4 because 4 doesn't go into 10. All right? So you need to sort of know a little bit of math, but I don't want you to write all this out. It just seems like a lot of extra work. Okay? I need you to pay attention here, though, because this is very important. The greatest common factor. What's the biggest number that goes into both? 2. So that's my greatest common factor for the numbers. What's the biggest variable that goes into both? X. So that's your greatest common factor. That's it. Okay? For their example, they gave us 4c squared d 6c d3. Okay? We want to find the greatest common factor. Instead of doing all this, we're just going to say, what's the biggest number that goes into both? 2. It's not 4 because 4 doesn't go into 6, so we know it's 2. Our numbers are done. What's the biggest c that goes into both? It's just c. No, not squared, because this one doesn't have a square. So just c. Now what's the biggest d that goes into both? Just d. That's it. That's your greatest common factor. 2cd. Okay? So instead of doing all this where you expand everything, just take it slow, take one at a time, and we can get it. Rudy, what's the biggest number that goes into both of these?
7.
Good, because we know 7 goes into 14. If you're not sure, you can use your calculator. 14 divided by 7 is 2. And then what's the biggest a value that goes into both? A. What's the biggest b value? And what's the biggest c value? Now this is tricky. Is it c? No, because the 14 doesn't have a c. Do you see that? Can you see that, Rudy? You understand why I'm not putting it there?